Hi, let's continue with the next section, 2.1, Graphs of Equations. Graphs display information and we can provide a visual approach to problem solving. We often see graphs in newspapers and magazines. Okay, to begin, let's establish some definitions about the rectangular coordinate plane. So what you see here is the rectangular coordinate plane. It's also called the Cartesian plane. I also hear it called the XY axis or plane. All of those are referring to this picture right here. So this is made up of two number lines. We have the x-axis, which is your number line that runs from left to right. And then we have your y-axis, which is your number line that runs up and down. That point where they meet is called the origin. The origin is the point 0, 0. These number lines separate to create four boxes. These boxes are called quadrants. We start with the first quadrant and then move counterclockwise to have the second, third, and fourth quadrant. Now, if you look closely, each set of numbers has positive or negative lists of numbers. So we see here in the first quadrant, all of my numbers are positive from my x-axis and all of my numbers are positive from my y-axis. If I take a look in my second quadrant, my x-axis are negative and my y-axis are positive. If I take a look at my third quadrant, both my x-axis and my y-axis are negative. And in the fourth quadrant, my x-axis is positive and my y-axis is negative. Okay, we use these labelings of numbers to create points so that we can plot points. So let's take a look at some points. If I'm being asked to graph the point 0, 4, then my x is my 4 and my y is my 0. So we see that's where these points meet. Or, let's do another example. We have the point 3, 5. A point is always given in the form x, y. So the way I go about it is I find my x on the x-axis, then go up or down y amounts. So let's say the example of 3, 5 that we see here. To find that point 3, 5, I find my 3. My 5 is positive, so I go up 5. Another way to go about it, or to think about it, is this is where these points meet. So if I draw a line, I see they would meet exactly that point. You can think of it whichever way seems best. I go about finding my x-axis or my x point, then going up and down my y. Okay, we have negative 4, 5. We find our point negative 4 and go up 5 to create that point there. This other example, negative 6, 4, I find my point negative 6, then go down 4 to find that point. What about points along the axis, like 0, negative 5? Moving forward, solutions to equations. If an equation has two variables, its solutions are pairs of numbers. When such a solution is written as an ordered pair, the first number listed is in the pair generally replaces the variable that occurs first alphabetically. However, we most commonly use x and y. All right, so let's talk about coordinate points. We will usually see x, y, but we can use any variable we'd like. If you see another variable, just keep in mind that it's always your first in the alphabet, followed by whichever one is next. Let's do an example. Determine whether each of the following pairs is a solution of 5b minus 3a equals 34, and we're testing the points 2, 8, and negative 1, 6. So let's start with the first one, 2, 8. All right, well, that first letter, that first number, we're working with A's and B's. This means my 2 would be an A, and 8 would be my B. Let's go ahead and replace those numbers so that I have 5 times B. What is B? Well, we said B is 8, right? Minus 3 times A. What did we say A was? A was 2. Equals 34. All right, 5 times 8 is 40 minus 6. Now, this whole time we're asking ourselves, hey, is this true? Does it equal 34? And 40 minus 6, yep, that is 34. So it checks out. So we can say yes, it is a solution. That would be our answer. Let's take a look at the next point. We have 2, oh, we already did that one. We have negative 1, 6, where A would be negative 1 and B would be 6. Okay, let's go ahead and replace those values. So I have 5 times B, my B is 6, minus 3 times A, my A is negative 1. We want to see, big question mark, if it still equals 34. All right, 3 times 6 is 30. 3 times negative 1 is positive 3. 3 times 30 plus 3 is 33, which is not equal to 34. So we would say no, it is not a solution. This is how we can test a point to see if it's solution, to see if it is a solution to the equation. Let's move forward to definition of a graph of an equation. The graph of an equation is a drawing that represents all of its solutions. Okay, we haven't touched much about graphing, but we'll develop the different techniques throughout the future sections. So to begin, when we don't know how to graph something or when we don't know how something will look like, one of the best ways to go about it is to create a chart. Let's create a chart as X. Give ourselves some room to show our work. And our answer will be Y. All of this is to create a point X, Y. Now, we can work however we want it. However, we see that our answer will always be Y, right? So it's up to us to plug in some value for X. Now, what do we plug in for X? You can plug in whatever you like. I think a safe way to go about it, just to make sure that you have plenty of points and that you have a good representation of your graph, is to create some positive, some negative, and maybe 0. So let's pick points. So we can plug in whatever we want for X. Let's plug in maybe negative 1, 0, 1, and 2. Now we chose these values. You could have chose whatever you wanted. If you want something else, you can do that too. Okay, so we're going to plug in 2 times X. And we chose these values for X. Okay, so we have 2 times negative 1. 2 times negative 1 is negative 2. So my answer, my Y, is negative 2. Remember, your answer is always as X, Y. So my answer will be negative 1, negative 2 as a point. Next, we have 0, 2 times x, which is 0. Well, 2 times 0 is 0, which gives me the point 0, comma 0. 2 times 1 gives me 2, so I have the point 1, comma 2. And 2 times 2 gives me 4. So I have 2, comma 4. Let's plot these points. So I have negative 1. Here we have a negative 1. I'm going to go up 2. Oh, I think that was down 2, right? Down 2. Down 2. I have 0, comma 0. I have 1 up 2. And I have 2 up 4. Okay, if I connect these points, we see we get a line. That is our first graph. Let's go on to the next example. Y equals negative 1/2 x plus 3. Same idea. We see we'll have an answer for y, and we're going to plug in a value for x. Now, as we look at our values for x, we see that we're going to be essentially dividing by 2. So as we pick these numbers for x, let's pick values that are even so that I can divide by 2 and hopefully not get some fractions. So let's pick numbers like negative 2, 0, and 2. Okay, let's go ahead and work this out. So we're going to replace our x with a number that we chose. We're going to multiply it so that we have negative 1/2 times 2 plus 3. Do you remember how to multiply fractions? If you have a whole number, you write it over 1 to write it as a fraction, and then you just multiply across. So I can multiply across. So that we have negative 1 times 2 is negative 2, and 2 times 1 is 2. 2 divided by 2 is 1, so we have negative 1 plus 3, we get 2. Next one. We have negative 1/2 x. Instead of x, I'll plug in the 0 plus 3. Well, anything times 0 is 0, so we're left with 0 plus 3. We get 3. 1 over 2 times 2 plus 3. Okay, write our 2 as over 1, and then we multiply across. So that we have 1 times 2 is 2, and 2 times 1 is 2. And I think I forgot the negative in the front, right? So that's negative 2 over 2. Plus 3, we get negative 1 plus 3, we get 2. I think I made a mistake in the very first one. We had negative 2, right? So this was supposed to be a negative 2, which this would make positive. So it was 1 plus 3, we get 4. Okay, so this gave us the points negative 2, 4, 0, 3, and 2, 2. Let's go ahead and plot them. So I have 0 up 4, negative 2 up 4. We have 0, 3, and 2, comma 2. That's our graph. Let's go on to our next one. So what's different about this one? This one, here we see that while all of our other equations were our answer y, and then everything else. So for this one, it would be worth our efforts to solve for y. First, solve for y. Okay, so we have 3x plus 5y is equal to 10. Let's go ahead and get y by itself. So we start off by isolating that term. So let's go ahead and move that 3x. So minus 3x, that's 0. Minus 3x, that's gone. And we're left with 5y is equal to negative 3x plus 10. Last piece, to get y by itself, I have to divide by 5. So we're left with y is equal to, now that 5 is dividing each number on the top, so that we have negative 3 over 5x plus 10 divided by 5, get 2. Okay, let's go ahead and create our chart. Now, when you're graphing, we're graphing lines, and we'll talk more about these specific about lines. When you're graphing a line, you really need 2 points. You might come across an instructor who wants more points, so you might recall a very strict high school or middle school teacher who wanted a lot more points, but 2 will get the job done. So let's just pick 2 points. We see that we are dividing by 5. So let's pick numbers that can be divided by 5. And 0. 0 is always a nice number to choose. So let's choose 0 and 5. Okay, so let's plug this in. We're left with negative 3 over 5. Our x will be 0 plus 2. Okay, well, anything times 0 is 0, so we're left with 0 plus 2. This gives us 2. Next one, negative 3 over 5 times 5 plus 2. Okay, well, if I write it over 1, these 5's can be divided out. You can cross cancel, it's also called that. And we're left with just a negative 3. Negative 3 plus 2 gives us negative 1. So we're left with 5 comma negative 1 and 0 comma 2. All right, let's graph our line. So I have 0, 2, and 5, negative 1. 5 down 1. And that is our graph. Now, all of these equations we work with have been lines. And how do we know they're lines? Well, if you take a look at their x's, my x's are all to the first degree. And we'll talk more about degrees, meaning they don't have an exponent. And if they did, well, they technically do. It is an exponent of 1. They have all been lines, but we also can have nonlinear equations. So to graph nonlinear equations, these are equations whose graphs are straight lines are called linear, but there are many equations whose graphs are not straight lines. For example, look at these nonlinear lines. This first one we have is called it comes from a quadratic, and this U-shaped figure is called a parabola. And we'll talk a lot more of this in detail in future chapters. Next, we have a polynomial. This one's a cubic. It's called a cubic because my highest exponent's a 3. But it still falls under a polynomial. So we have these graphs for us to try. But actually, I'm going to skip them for now. I think if we go through them, it'll be more confusing than helpful. We'll talk more about these graphs in future chapters. Maybe you won't talk about rational equations or rational functions into your college algebra class. We'll talk about those a lot. They're their own chapter. Yeah, we'll skip those for now. When I created this lesson, I thought it would be really worth our while to create a chart like we did before, but now I think it would be more confusing than helpful. All right, that's it for this section. For this section, we introduced lines and how to check for a point to see if it's a solution and how to graph a line. We were also introduced to the rectangular coordinate plane. Thanks.